Hi everyone, today we're going to be talking a little bit about observing matter and really what are some of the different properties that we can use to observe matter through experimentation and just the world around us as well. This is Learning Target 1.2. We're going to be doing some practice with this as well next Monday, and our quiz will be coming next week. So our goal today is to be able to observe matter using physical and chemical properties and changes. So first we're going to start talking about just what a physical property versus a chemical property is, and then what some physical and chemical changes could be. So physical property, this is any property that you can directly observe without causing any change to the matter that you're looking at, or without causing any sort of chemical or irreversible change to the matter. These are typically going to be some things that you can observe with your five senses, so things you can see, hear, taste, touch, and smell. In chemistry class, we are not going to be tasting chemicals, so you can kind of eliminate that right off the bat. These might also be changes that we can observe by heating or cooling a substance that wouldn't necessarily change it chemically. It might just give us some information about how it melts or how it freezes and so on. So here are some of those physical properties that we can observe with our senses. So we can observe the hardness of something, its flexibility, brightness, boiling point, and melting point are big ones that we frequently use in chemistry. Something's density, or how much matter we see in the amount of volume of something that we have. Length we can be measuring, fluidity we can look at, electric charge, pressure, volume, area. All of these things are things that we can view with our senses, things that we can measure that don't cause any change to the substance. So I can measure the length of a piece of metal without changing the fact that it's metal. Chemical properties are essentially any property that defines how something will behave chemically. Typically, this is going to be something that we can only observe by actually causing a substance to undergo that change. So here we can see some examples on the bottom. So if I put zinc in acid, I will see that that will undergo a chemical change. So I know that zinc reacts with acid. That would be a chemical property of zinc. I know that sulfur can burn in air. That would be a chemical property of sulfur. And again, I could only observe that by actually burning the sulfur, which would change it to something different. And then here, iron rusts or oxidizes in air. So this would be a chemical property of iron, again, that I can only observe by actually causing rusting to occur. So here are some other examples. So we have heat of combustion. This is basically how hot can something get in order for it to catch on fire. So fire. If it's reactive with water, what the pH is. So this is telling about acidity. Flammability of something, so can it catch fire, or is it fairly fire resistant? Is it toxic? Is it chemically stable versus unstable? Will it break down easily? And then enthalpy of formation, we're going to be talking more about this later in the school year. This is the amount of energy it takes for a chemical substance to form. So when you think enthalpy, think energy. Okay, so those are some of the different properties. We can also observe changes that matter is undergoing as well. So we can have a physical change or a chemical change. So a physical change is a change that occurs that does not create a new substance. Notice here, physical properties I can observe without changing what the substance is. Physical changes are changes that do not create a new substance. So this could be taking some copper and I could be melting the copper like I see in the picture below here. This could be boiling water. This could be tearing a piece of paper in half. Those would be physical changes to the substance. It might change what the substance looks like, but it doesn't change what it is. Melted copper is still copper. A piece of paper torn in half is still paper, and so on and so forth. So here, a really typical or a really common physical change that we see a lot in chemistry are changes in state. So these should look fairly familiar to you. So we have when things change from a liquid to a solid, we call that freezing or solidification. Solid to liquid, that's melting. Liquid to gas, that's evaporation. Gas to liquid, condensation. And then these ones over on the right hand side, they may be less familiar with to you, but we do see some of these examples in everyday life. So solids going to gas, that's sublimation. We actually see that with dry ice. And gas going directly to solid or deposition. We actually see that when frost forms on grass and on your car on really cool mornings, particularly in the fall and early in the winter. Chemical change is different from a physical change because a chemical change is actually going to change what the substance is chemically. So it's changing the arrangement of atoms. And really it's changing how those atoms are bonded to one another. So they may be incorporating something new in bonding. We may be splitting bonds apart. Either way, it's changing what the substance is. So here an example, just everyday life example. If I have had flour and sugar and chocolate and eggs and baking soda and oil, and I put that in the oven, a chemical change would occur that would turn that into brownies. Also, typically with chemical changes, you're going to be looking for changes that happen to something that are irreversible. So it changes it into something new, and I can't go back. I can't change this back into sugar and flour and chocolate isolated. There are some signs in the lab that we're going to be looking for in terms of identifying when something is undergoing a chemical change. So one thing that you can be looking for is does it spontaneously give off or take in heat? So endothermic, meaning taking in heat, exothermic meaning given off. We're going to be talking more about these terms later in the school year. But if I pour two things together and all of a sudden it feels cold, or if I pour two things together and all of a sudden it feels warm and I haven't actually applied heat to it, that would be a sign that a chemical change has occurred. Another one is the formation of what's called a precipitate. The formation of a precipitate, this means solid. So anytime I'm forming a solid where one wasn't before, so if I take two liquid chemicals, pour them together, and I see a solid form, that would be an example of the formation of a precipitate. And often we're going to see that really just as the liquid looks like it becomes cloudy. So that is a really typical example that we see in chemistry. Another sign of a chemical change would be if a gas is given off. If a gas is being given off in a chemical reaction, you're going to see that as bubbles, typically, because gases are usually colorless. Or more typically colorless, especially in the reactions that we're going to be doing. You're going to be looking for the formation of those bubbles. That tells me that a gas is given off. So here in the example, I have a liquid component that is mixed with a solid, and all of a sudden I have these bubbles forming, which means that I have a gas forming. So I had a liquid and a solid, and now I have a gas without actually heating anything. So that would be an example of a chemical change. Don't get this confused with boiling. So if I heat water until it's bubbling, a gas is being given off, but the gas that's being given off is just water vapor. So no chemical changes happen there. So be careful with that. If heat is being applied externally, typically that might change things a little bit. And then finally, color change. So if I take two clear colorless liquids or two liquids that are different colors, pour them together and it forms a new color. So here I see two clear colorless liquids that form together to form this yellow color. That would be an example of a color change. Again, don't get a common mistake that I see here is students think that, okay, I added food coloring to water, the water changed color, so that's a chemical change. Wrong. The food coloring was already, let's say, red. I added it to the water. Now I just have a mixture of water and food coloring. So there was no chemical change that happened there. So just be careful about some of those things. If you have questions as we're going through this, please ask. Remember, these are things to look for when we're in the lab, but always be asking yourself, is the substance the same thing as it was before? Is this reversible? Those are good questions to ask in terms of differentiating between these different processes when we're making observations in the lab. We're going to be getting some practice with this on Monday. And then next week, we're also going to be doing a lab where you guys are going to be observing some different physical and chemical changes and trying to kind of differentiate and make really good observations from those. So we can get some good practice, one, with some lab procedures, and two, with just getting familiar with making these observations of matter.